everyone. So in today's class, we shall see kernel of homomorphism. In today's class, we shall see the kernel of homomorphism and their examples, their theorems of kernel of homomorphisms. Okay. Kernel of homomorphism. Kernel of homomorphism. Okay. What does kernel of homomorphism say? Okay. Let us see the figure. Okay. If f colon g tends to g bar is a homomorphism is a homomorphism then the set of all those this is all. Okay, why is it coming here? This is all those elements of G where which are mapped into E bar, the identity of G bar is called kernel of homomorphism. I will be writing in short form KH, means kernel of homomorphism. It is denoted by we write in by capital K or Krish. Okay. Then therefore it must satisfy the condition. It also has a condition K is equal to, sorry, this is not an Z is equal to G belongs to G by F of G is equal to G bar. Okay. F of G is equal to E bar. Okay. So now let us see what this says. In homomorphism, we saw that already. F of A star B is equal to F of A into star F of B. Okay. They are doing some dot or something they are doing. So what does this homomorphism say? F of A star B is A dot B is equal to F of A into F of B. Okay. In kernel of homomorphism, see what does it says that if F tends to F colon G tends to G bar means G bar mapping is a homomorphism. That should be a homomorphism. Then the set of all those elements of G. Notri, diagram understand diagram easy understand. Okay, ಇದು G na next mapping ನಮಗೆ G ಬಾರಿ okay G ಬಾರಿ okay E na colon so f of a dot b is equal to ಏನು ಇವಾಗ f of a into f of b okay na this is how we write so the question pattern ಇದೆಲ್ಲ ಇದ್ರಾಗ ಮಿಕ್ಸ್ ಮಾಡ್ಕೊಬೇಡ್ರಿ this is separate and this is separate so ಇಲ್ಲಿ ಮ್ಯಾಪ್ ಆಗತ್ತದ so ನಮಗೆ ಇದು ಏನಾಗ್ತದ ಇದು ಕರ್ನಲ್ ಆಫ್ ಹೋಮೋಮಾರ್ಫಿಸಮ್ ಆಗ್ತದೆ so ನೆನಪಿನ all those elements of g ಎಲ್ಲಾ elements of g which are mapped into g bar ಇದು ಹೋಗಿ ಮ್ಯಾಪ್ ಆಗತ್ತದ g bar so ಈ ಬಾರಿಗೆ ಇಲ್ಲಿ ಈ ಬಾರ್ ಅಂತ ಇದು is identity g bar is called as kernel of homomorphism simple example ಇದೆ confusion ಬೇಡ if f colon g tends to g bar is a homomorphism so ಏನಂದ್ರೆ g tends to g bar is a homomorphism then a set of all those elements of g ಇದು g ನಂದು ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ g ನಂದು ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ನೋಡ್ರಿ which are mapped into e bar ಹೋಗಿ ಇಲ್ಲಿ ಮ್ಯಾಪಿಂಗ್ ಆಗ್ತಾವಲ್ಲ ಇಲ್ಲಿ ಹೋಗಿ ಮ್ಯಾಪಿಂಗ್ ಆಗತ್ತ ಒಂದಕ್ಕೆ ಹೀಗೆ which are mapped into e bar ಇಲ್ಲಿ ಹೋಗಿ ಮ್ಯಾಪಿಂಗ್ ಆಗತ್ತ ಒಂದೇ e bar this identity of g bar ಇದಕ್ಕೆ ಏನಂತೀವಿ ಹೋಲಿಗೆ g bar ಅಂತೀವಿ is called kernel of homomorphism okay ನೋಡ್ರಿ ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೀನಿ if f colon g tends to g bar is a homomorphism ಇದು g tends to g bar homomorphism ಅಂದ್ರೆ ಮ್ಯಾಪಿಂಗ್ ಆಗತ್ತೆ all those elements of g mapped into g bar ಆಗದಕ್ಕ the identities of g bar ಈ g bar ಏನಂತೀವಿ ನಾವು ಈ g bar ಏನಂತೀವಿ ಈ g bar ಗೆ kernel of homomorphism ಅಂತ ಕರೀತೀವಿ this is a kernel of g bar this identity g bar is called kernel of homomorphism it is denoted by ಒಂದು ನಾವು ಕ್ಯಾಪಿಟಲ್ k ನಿಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ or tree KREF ಅಂತ ಹೇಳಿ ಟ್ರೀಫ್ ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ ಈ ಎರಡರಾಗ ಒಂದನ್ನ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ ಸೊ ನೆಕ್ಸ್ಟ್ ಏನಾಗ್ತದೆ ಇದು ಹೆಂಗ್ ಡಿನೋಟ್ ಮಾಡಿದ್ದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಏನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕು ಅಂದ್ರೆ ಕ್ಯಾಪಿಟಲ್ K is equal to small g belongs to capital G slash g f of g bar is equal to e bar f of g bar ಇದ್ದು ನೆಕ್ಸ್ಟ್ ಹೋಗಿ ಏನಾಗ್ತದೆ ಅಲ್ಲಿ e bar ಆಗುತ್ತೆ ವ್ಯಾಲ್ಯೂ ಓಕೆನಾ this is how the kernel of homomorphism this is how the kernel of homomorphism definition says okay so next we shall see the some two theorems of the kernel of homomorphism okay in next page we shall see the theorems of kernel of homomorphism so next theorem if f colon g tends to g bar is a homomorphism then the set of all there is a light change here so I'm writing some different sorry the mistake I have made the kernel of homomorphism sorry the kernel of homomorphism the kernel K of the homomorphism f colon g tends to g bar is a normal subgroup is a normal subgroup of G So statement in answer, the kernel K of homomorphism that G colon F colon G tends to G bar is a normal of a normal subgroup of G. So ಏನಂತಿದ್ದಾರೆ ಒಂದು kernel of homomorphism ಇದೆ, ಆ G ಇದೆ, ಇನ್ನೊಂದು G bar ಇದೆ. So that is mapping. So that is mapping ಆಗತ್ತಿದೆ. So as x square is 2x something. So mapping ಆಗುತ್ತಿದೆ ನಮಗಿದು. ಈ ಮ್ಯಾಪಿಂಗ್ ಆಗ್ತದ ಇದಕ್ಕೆ ಏನಂತಾರ ಏನ್ ಪ್ರೂವ್ ಮಾಡಂತಾರ ದಟ್ ಈಸ್ ಎ ನಾರ್ಮಲ್ ಸಬ್ ಗ್ರೂಪ್ ಆಫ್ ಜಿ ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡಂತಾರ. ದಟ್ ಇಸ್ ಎ ನಾರ್ಮಲ್ ಸಬ್ ಗ್ರೂಪ್ ಆಫ್ ಜಿ ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ವಿ ಶಾಲ್ ಸಿ ದ ಪ್ರೂಫ್. Normal subgroup of G. Next, we have K is equal to G belongs to capital G slash f of G bar is equal to E bar. Okay. So since the definition of kernel of homomorphism K is equal to G belongs to G slash f of G bar is equal to E bar. Okay, is the expression for it, kernel of homomorphism. So next we shall see since f of E is equal to f of E ಅನ್ನೋದು already ನೋಡಿವಿ, f of E is equal to E bar, therefore that implies f of E is equal to E bar ಇತ್ತಂದ್ರ E belongs to capital K ಆಗುತ್ತೆ. Okay, so this E bar belongs to same. Okay, so we write this E belongs to capital K, therefore capital K ಯಾವಾಗಲೂ ಇರ್ತದೆ non empty ಇರ್ತದೆ. capital K is non empty is non-empty. Okay, ಯಾವಾಗಲೂ non-empty ಆಗಿರುತ್ತೆ. Even every G belongs to K is an element of G, that is belongs to K subset G. Okay, first we show that K is a subgroup of G let A comma B belongs to arbitrary, B belongs to K, B arbitrary. Okay, now by the definition of K, okay, by the definition of K, okay, by the definition of next K, that is f of A is equal to E bar and f of B is equal to E bar. Okay, so therefore f of A is also equal to E bar and f of next B inverse here, B inverse E bar. Okay, so next what we did finally. So we have this k is equal to g belongs to capital G slash f of g bar is equal to e bar. So we have f of g bar is equal to e bar. In the previous theorems, we have studied that f of e is equal to e bar. So theorem number 37. Theorem number 37 ಅಲ್ಲಿ ನಾವು read ಮಾಡಿದ್ದೇವೆ. Okay. Theorem ಅಲ್ಲಿ f of e is equal to e bar. Therefore, f of e is equal to e bar ಅಂದ್ರೆ we can say that e belongs to capital K. That K is a E belongs to capital K ಅಂತಂದ್ರ suppose ಏನೇ ಅಲ್ಲಿ E belongs to G or E belongs to something K or E belongs to something ಇತ್ತಂದ್ರ ಅದು ಯಾವಾಗಲೂ K is a non-empty ಆಗಿರ್ತದೆ. ಅದು ಯಾವಾಗಲೂ ಟರ್ಮ್ ಎದಕ್ಕೆ ಬಿಲಾಂಗ್ಸ್ ಆಗಿರ್ತದೆ ಆ ಟರ್ಮ್ ಯಾವಾಗಲೂ ನಾನ್ ಎಂಪ್ಟಿನೇ ಇರ್ತದೆ. ಇಟ್ ಇಸ್ 100% ಶ್ಯೂರ್ ಅದು ಯಾವಾಗಲೂ ನಾನ್ ಎಂಪ್ಟಿನೇ ಆಗಿರುತ್ತೆ. ಓಕೆ, every G belongs to capital K. Okay, so every small g belongs to capital K is an element of G. Therefore, we write K is a subset of G. So, below the value G belongs to K. So, K is K value. So, we write small g belongs to K. Therefore, we can write that element of G is that implies K is a subset of G. So, first we should say that K is a subgroup of G. So ಇದಕ್ಕಿಂತ ಬರ ಏನಬೇಕು ನಾವು K is a subgroup of G ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು ನಾವು ಫಸ್ಟ್. So K is a subgroup of G ಅಂದ್ಮೇಲೆ ನಮಗೆ next steps K is a normal subgroup of G ಅಂತ ಬರ್ತದೆ. Okay, first we should prove that K is a subgroup of G. So K is a subgroup of G ಪ್ರೂವ್ ಮಾಡಬೇಕಲ್ಲ ನಮಗೆ. So next what we do is let A, B belongs to capital K. So what we do, A, B belongs to capital K, we be an arbitrary means we are considering here. So ಇದು ಎಲ್ಲೂ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನ ಎಲ್ಲೂ ಕೊಟ್ಟಿಲ್ಲ. ಸೊ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇರ್ತೀವಿ A ಮತ್ತು B ನ. ಓಕೆ, ಸೊ ಕನ್ಫ್ಯೂಷನ್ ಆಗಬೇಡ್ರಿ. A ಮತ್ತು B ಎಲ್ಲಿಂದ ಬಂತು ಕರ್ನಲ್ ಆಫ್ ಹೋಮೋಮಾರ್ಫಿಸಮ್ ನಮ್ಮ ಮ್ಯಾಲಲ್ಲೂ A ಮತ್ತು B ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿಲ್ಲ ಸರ್, ಅಲ್ಲಿ ನಮಗೆ ಹೆಂಗ್ ಬರ್ತದೆ. We are considering A and B. So A and B belongs to capital K, be an arbitrary by the definition of K. So definition of kernel of homomorphism. Definition of K ಅಂದಾಗ kernel of homomorphism ಯಾವಾಗಲೂ ಆಗಿರಬೇಕು. So f of A is equal to e bar and f of B is equal to also e bar ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. So next as usually f of A is equal to e bar and f of B inverse is equal to e bar ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. So ಎರಡಕ್ಕ e bar ಮತ್ತು f of A is equal to e bar ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. As usually f of B inverse ಅನ್ನು ನಾವು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತೀವಿ, e bar ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So next type is that is equal to, that implies f of A is equal to e bar and f of B whole inverse is equal to e bar. ನಾನು ಥಿಯರಮ್ ನಂಬರ್ 37 ಇದಿಷ್ಟೇ ಪಾರ್ಟ್ ಹ್ಯಾಂಗ್ ಬಂತು ಅಂತ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ವಿ ನೋಡ್ರಿ. ಅದು ವಿಡಿಯೋಸ್ನು ಇರ್ತಾವ ಯೂಟ್ಯೂಬ್ ನಲ್ಲಿ. ಸೊ ಯಾರು ಸಪೋಸ್ ನೋಡಿದಿಲ್ಲ ಹೋಗಿ ನೋಡ್ರಿ ಏನಾಗಿದೆ ಅಂತ ಹೇಳಿ. ಸೊ ಆಮೇಲೆ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ರಿ. ಈ ಸ್ಟೆಪ್ಸ್ ಅನ್ನ ಈ ಸ್ಟೆಪ್ ಅನ್ನ ಎಲ್ಲಿಂದ ಬರ್ದಾರಂತೆ ಬರ್ದಿರ್ತಾರೆ ಬೈ ಥಿಯರಮ್ ನಂಬರ್ 37 ಅಂತ ಬರ್ದಿರ್ತಾರೆ ನೋಡ್ರಿ. ಯಾಕಂದ್ರೆ by theorem number 37 we got this as equation number 1 ಅಂತಲೇ ಸಿಗುತ್ತೆ ನಮಗೆ. ಓಕೆನಾ? So next, now to show that AB inverse belongs to capital K, consider f of AB inverse is equal to f of A into f of B inverse. Okay, f of A into f of B inverse ಆಗುತ್ತೆ. ಓಕೆನಾ? f of A into B inverse ಆಗುತ್ತೆ. Therefore f of A value ನಮಗೆ ಆಲ್ರೆಡಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿರೋದು e bar and f of B inverse ನಿಂದ ಅದನ್ನು e bar. So E bar into E bar we shall write as f of AB inverse is equal to, directly we shall write as E bar. Okay, E bar. Okay, this is by equation one. Okay, so therefore AB inverse belongs to capital K for all A comma B is equal to, sorry, belongs to K. Okay, A comma K belongs to capital K. A comma B belongs to capital K. Okay. So next, therefore K is a subgroup of G. Subgroup of G. Subgroup of G. Okay. K is a subgroup of G. So what we did from the first in this page, we shall see that now. So here f of A is equal to E bar and f of B whole inverse is equal to E bar. This is equation number 1. ಇದು ಇಷ್ಟೇ ಪಾರ್ಟ್ ಹೆಂಗ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿರಂದ್ರ ಸೊ ಪ್ರೀವಿಯಸ್ theorem of theorem number 37 theorem number 37 in previous videos I have told this how we consider this. So is equal to E bar, now showing that AB inverse belongs to capital K. So now we shall take that, we shall take f of AB inverse is equal to, by the definition of the node definition, not confusion under it. F of B inverse is equal to f of A into f of B. The value of f of A is equal to E bar, f of B is equal to E bar. So now the E inverse is equal to E bar is equal to f of AB inverse is equal to E bar. Therefore AB inverse belongs to capital K, A comma B belongs to capital K. Therefore K is a subgroup of G. ನಮಗೆ ಏನು ಸಿಕ್ಕಿತು? K is a subgroup of G ಸಿಗುತ್ತೆ. What we have to read? K is a normal subgroup of Brahmanda. So next steps are, next screen I will be sharing this. So next screen is further to show that K is a normal subgroup and direct NSG andre normal subgroup antare we establish now prove we establish that for all x belongs to G, for all A belongs to K, next x inverse AX is belongs to capital K. So considering now I will consider what you are sorry. So consider f of x inverse AX is equal to f of x inverse f of A into f of x is equal to f of x inverse, the f of A value is E bar. Okay, E bar taking as usual writing f of x, that is A belongs to capital K by definition K. Okay, by definition K. Therefore f of x whole bar into f of x, we neglect this, E bar is 1, so we write f of x inverse AX is equal to E by the definition of this is by definition of K as well as x inverse of Ax is equal to K for all x belongs to G. Okay, next for all A belongs to Bilma. So therefore I will write it here. Hence K is a normal subgroup of G. Okay, K is a normal subgroup of G. Okay, K is a normal subgroup of G. So in last frame what we have discussed further to show that improve ಮಾಡಿದ್ರಿ NSG prove ಮಾಡಿದ. We established that now in consider ಮಾಡ್ಕೊಂಡಿದ್ರಾ x belongs to x belongs to G ಅಂತ ನಮಗೆ already question ಅದ. Therefore A belongs to K ನು ನಮಗೆ already ಗೊತ್ತದ. So ಎರಡು x ಮತ್ತು A belongs to ಇದಂದ್ರ we can write that subgroup normal subgroup in normal sub by using by using normal subgroup we can write this. Okay, by using normal subgroup we can write this. Okay, x inverse Ax belongs to capital K. Therefore f of x inverse Ax is equal to here f of x inverse f of A into f of x. So f of x whole inverse, this is f of A value e bar. So next f of x as it is, by we can say that f of x whole inverse into x whole f of x is the value of this is e bar. Okay, this whole value in previous terms I have said. So day by day yaar ottira avrige values kunata. So day by day yaar continuous agi touch irla avrige values ಏನಂತ kuna agalla. So ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ನೀವು daily repeat ಹಾಕೋತಾ ಇರಬೇಕು. So ಅಂದ್ರಾಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ತದೆ. So f of x inverse Ax is equal to E. This is how by the definition of K. K means kernel of homomorphism. Okay, so this is x inverse Ax belongs to K for all x belongs to G. So this K is a normal subgroup. K is a normal subgroup. Okay, so then next we shall see so next we shall see the one more theorem number 42. Okay, one more theorem we shall see. If G colon sorry F colon G tends to G bar, this is G bar is a homomorphism and K is kernel of F, kernel of F, then F is 1 to 1 if K is equal to E. Therefore next we shall prove here in a quotation they have given E is an identity of G. E is an identity of G andre consider ಮಾಡೋಣ. So what does F ಏನಂದ್ರೆ G to G bar mapping ಆಗತ್ತಲ್ಲ, is an homomorphism ಅಂತ, and K is a kernel of F ಅಂತ ಹೇಳ್ತಾರೆ. Then what to prove is F is 1 to 1 mapping ಅಂತ ತೋರಿಸ್ರಿ ಅಂತ ಹೇಳ್ತಾರೆ. F is an 1 to 1 mapping ಅಂತ prove ಮಾಡತ್ತ. Okay, so next in proof we shall see here in F we shall see here one second. We shall see proof. First suppose that F is 1 1 1 1 1 1. Therefore we consider that for all x1 comma x2 belongs to G. Therefore, f of x1 is equal to f of x2. That implies x1 is equal to x2. Na? X1 is equal to x2. That's what's right. So now for all A belongs to K, we have f of A is equal to E bar. E bar is being identity as G bar. E bar in question they have given E bar being the identity of G bar. Okay. Therefore, f of A is equal to f of E. So that is A is equal to E. F of E bar F of E can tell E bar is not. So A suppose that F is 1 to 1. I mean, F is 1 to 1. Suppose we are considering. So let us take for x1 and x2. Consider that belongs to G and so therefore f of x1 is equal to f of x2. Okay, f of x1 and f of x2. Already noted x1 x2 belongs to G and therefore x1 is equal to f of x1 is equal to f of x2. Therefore we can say that x1 is equal to x2. This is equation number 1. Now for all A belongs to K. So already mapping onto mapping onto mapping hinge barutte or onto one hinge agutte ಇನ್ನೊಂದು ಡಾಟ್ಸ್ ಇನ್ನೊಂದು equation ಶಿವಾಗಿ ಜಾಯಿನ್ ಆಗುತ್ತೆ 2 ಕಿಂತ more ಇರುತ್ತೆ onto mapping ಅಂತ ಹೇಳಿದ್ರೆ so A belongs to K we shall show that f of A is equal to E bar f of A is equal to E bar ಅಂತ ನೋಡಿ that E bar is being identified of G bar. So already in question given E bar is identified as G bar ಅಂತ so next f of A is equal to f of A is equal to f of E. That's f of E can be written as E. A is equal to E. Okay. So next I'll be showing next. Every element of K is E. K is E. Okay. Element of K is E. That implies K is equal to E. Therefore, conversely we shall start. Conversely, suppose that K is equal to E andre hang prove ಮಾಡ್ತೀರಾ to establish to show that f is 1 to 1 f is 1 to 1 we establish f of A is equal to f of B. That implies A is equal to B. F of A is equal to f of B, then directly we can say A is equal to B. Therefore, for all A comma B belongs to G and K. Now consider f of A is equal to f of B is equal to f of B. That implies f of A power of f of B inverse of B whole inverse that we say that f of B into f of B f of B inverse B whole inverse of B whole inverse f of B whole inverse that is f of A into f of b inverse is equal to e bar. Therefore, f of a b whole inverse is equal to e bar. Okay. So, nodri. Next, for every element k is an e and prove ಮಾಡಿದ್ರು ಅಲ್ಲಿ. Therefore, k is equal to e and suppose that conversely part ಮಾಡಬೇಕಾದ್ರೆ k is equal to e and ಬಂತು. Next, k is an k suppose conversely suppose k is equal to e ಅಂತಂದ್ರೆ now what if next thing 1-to-1 function ತೋರಿಸ್ತಾ ಇತ್ತಂದ್ರೆ f of a is equal to f of b ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳಿ. Therefore, f of a is equal to f of b ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. a is equal to b ಬಂತು. So a is equal to b ಆದಾಗ a b belongs to j ಆಗುತ್ತೆ. So therefore consider f of a is equal to f of b. As usually f of a into f of b whole inverse is equal to f of b into f of b inverse ಆಗುತ್ತೆ value. So by kernel of homomorphism, because we multiply both side by here we multiply by post multiply by f of b inverse b whole inverse ನೋಡಿ f of b whole inverse ಗೆ ನಾವು ಇಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಈ ಎರಡು ಟರ್ಮ್ ಗೆ ನಾವು ಇಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ. post multiply ಅಂದ್ರೆ f ಆಗೋಣ ನೆಕ್ಸ್ಟ್ ಆಗೋಣ f of a ಆಗೋಣ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ವಿ. ಇಲ್ಲಿ f of b ಆಗೋಣ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ವಿ. ಓಕೆ. ಸೊ ಏನಾಗುತ್ತೆ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ f of a into f of b inverse is equal to f of b and f of b in b whole inverse value ಇರುತ್ತೆ e bar ಆಗುತ್ತೆ. Therefore we can write f of a b whole inverse is equal to e bar ಅಂತ ಬರ್ತೀವಿ. ಓಕೆ. ಸೊ ಇಷ್ಟು ಮಾತ್ರ ಈಗ ತಿಳಿದ ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು 2 ಸ್ಟೆಪ್ಸ್ ಇದೆ. So we came to know that AB inverse belongs to K. Okay, that's the definition of kernel of homomorphism. Okay, the definition of homomorphism. Therefore, AB inverse is equal to E by. So next, f of B inverse into b. So ಇಲ್ಲಿ b ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ ನೋಡಿ. ಯಾವಾಗ ಸರ್ ಪೋಸ್ಟ್ ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಪೋಸ್ಟ್ ಮಲ್ಟಿಪ್ಲೈ ಬೈ b. ಓಕೆ. ಸೊ ಇಲ್ಲಿ as usual ab ಬರ್ತೀನಿ. ಸೊ ಇಲ್ಲಿ ab ಬರ್ತೀನಿ. ಆಮೇಲೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಕ ಪೋಸ್ಟ್ ಅಂತ. ಓಕೆ. Therefore a dot b is equal to a dot e is equal to b. So a ನ as it is ಇಟ್ಕೊಂಡು db inverse ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ ನಮಗೆ e ಆಗುತ್ತೆ. So therefore e into e ವ್ಯಾಲ್ಯೂ ಅನ್ನು 1 ಅದ. Therefore we shall write e value ಅಂದ್ರೆ 1 ಅದ. 1 into b ಮಾಡಿದಾಗ b ನೇ ಬರ್ತದೆ. So next e value ಅಂದ್ರೆ a, so a is equal to b ಅಂತ ಬರುತ್ತೆ. For all a belongs to a, b belongs to g. Okay, this is how f of a is equal to f of b. This is hence f is onto mapping into 1-to-1 mapping. Okay, this is how you can say that f of a is equal to f of b. Hence f is a 1-to-1 mapping. So in tomorrow's class I will be explaining the fundamental theorem of a kernel of homomorphism. After that I will be explaining one theorem. After that you may finish the chapter number 1. After that I will be saying the next. Tomorrow I will finish your group concept. Afterwards that I will be saying the Riemann integration. Okay, thank you.